Hey folks, welcome back. Happy Monday. Today, and just kind of generally in this week, we're going to be working on forces. So today we'll be talking about Newton's fourth law, or Newton's law of gravitation. And we're going to learn how to calculate the gravitational force exerted by planets and things like that using this law. Okay, so real quick, what is Newton's laws of gravitation? Newton's laws of gravitation are F equals big G, the gravitational constant, times the mass of one object, the mass of another object, divided by the radius squared. What I would like you guys to do is anything that I write down on the whiteboard, I want you guys to write down in your notes. Because that way you'll be able to answer the practice problems and use those notes as a guide. Okay. So, let's start with big G. What is big G? G is what's called the gravitational constant. A constant is something that doesn't change no matter what. There are a couple of numbers in our universe that are always the same. Pi is always 3.14. Is an example of something that is a constant. And G is always going to be 6.67 times 10 to the negative 11th units. Okay. Don't worry too much about big G's unit. It has that unit so that it cancels out with the other units in the equation. It's not something that's going to pop up a lot, and it's not something that ever really changes. Okay. Cool. So, what we're going to do is we're going to do a practice problem. Let's say, for example, that there is a planet, Mars. There is, right? Here's Mars. And on that planet is a person. We'll call that person Manny. Okay, so Manny is on Mars. What we're going to do is we are going to try and figure out the gravitational force between Manny and Mars. How hard is the planet of Mars pulling on Manny? Okay, so there are a couple of different things that we know. Let's identify what we know. So for one, we know the gravitational constant. That's always going to be the same. We also know the mass of Mars, which is 6.46 times 10 to the 23rd kilograms. We also know the mass of Manny, which is 65 kilograms. We also know the radius of Mars, or basically the radius between the center of Mars and the surface where Manny currently is. So that radius is 3.39 times 10 to the 6th meters. Okay. And using these three numbers, we want to try and calculate the amount of force being exerted by the planet on Manny, and vice versa. Okay, what I'd like you guys to try and do is to actually try and solve this problem right now. Even though you've never seen an example of these problems, you can plug these numbers into the equation. There are a lot of different places you can make mistakes, so make sure you're very careful about your steps. Show your work, so that way, if you make mistakes, you can see where you made those mistakes so that you don't make them in the future. Go ahead, pause the video, and when you're ready, we'll go over the problem to see if you got it correct. let's go over this problem and see if you got it correct. So, let's plug our numbers into the equation. We've got our gravitational constant G times the mass of object 1 and the mass of object 2. It doesn't matter if you put the mass of Manny first or the mass of Mars first. I'm going to put the mass of Mars first since that was the first mass I had. Times 6.46 times 10 to the 23rd kg times 65 kg divided by the radius of the planet. So that's going to be 3.39 times 10 to the 6th meters. All right. The one mistake that people typically make in their substitution step is that they forget about r squared. Everybody remembers to write in r, but it's very easy to forget that it's actually the radius squared. All right. There are a lot of other ways that people can make mistakes during the math steps, particularly when we're writing in scientific notation. All of these powers and times 10 to the power of can really throw people off. So I encourage you guys to do your math steps in multiple steps to avoid making those simple calculator mistakes. All right. What I'm going to do is I'm just going to get rid of this squared. I'm going to kind of factor that out and see what that's going to equal. So the first part of my expression really isn't going to change a whole lot. We're still going to have F equals 6.67 times 10 to the negative 11th Newton meters squared divided by kilograms squared. We could do the top. That should be fine. So if I take 6.46 times 10 to the 23 times 65, that's going to be 4.2 times 10 to the 25th kilograms squared. And we're going to divide that by 3.39 times 10 to the 6th meters squared, which should come out to be 1.15 times 10 to the 13th meters squared. Nice. A big calculator mistake that often happens is in this next step. People just kind of punch these numbers into their calculators manually, and it sometimes is going to spit out a number that's either really, really big or really, really small, and that's not right. What I encourage you guys to do is when you're entering the numbers into your calculators, make sure you always put the kind of scientific notation numbers in parentheses, just so that you don't get any kind of weird calculator errors or anything like that. Okay. So we'll take 4.2 times 10 to the 25th divided by 1.15 times 10 to the 13th. So the force in between the planet and the person is going to be 6.67 times 10 to the negative 11th Newton meters squared divided by kilograms squared. And we're going to multiply that by 3.65 times 10 to the 12th kilograms squared meters squared. And in case you're not seeing it, this 3.65 times 10 to the 12th simply came from me dividing these two numbers. Last step, I'm going to multiply these two numbers together. Meters squared divided by meters squared is going to cancel out. And kilograms squared divided by kilograms squared is also going to cancel out. When I take my numbers and I multiply them together, I should end up getting 243.5 newtons, which is correct. If you did not get this as your answer, that's okay. It's probably just how you entered the numbers into your calculator. Go back and make sure every single time you're entering these numbers in your calculator, you're not forgetting a negative sign, you're not forgetting to square your radius, you're not, forgetting to put your scientific notation-based numbers in parentheses, because all of those things are ways that can screw it up. Keep trying this problem until you can get the calculator to say 243.5. If it's off by like 0.1, that's not a big deal. All right, you'll be getting a very similar answer for your exit slip today. I'm basically going to ask you to calculate the force exerted on a person on Earth, which is kind of cool. And then we'll do other things with that this week, and you'll be able to calculate things like the acceleration of gravity on Earth and other cool things like that. All right, I'll talk to you guys more tomorrow. See you then. Bye.